Let us now see blinking an LED with ESP32 module. For this we will have to add a circuit diagram and I will explain how I have done it. This is the chip that I have put on a board, and these are the various pins you can see. These have been labeled as ground, G23, 22, transmitter, receiver. These are for UART. G21 again ground, 19, 18, etc. So these are the various pin numbers, and whichever pin starts with G followed by a number, for example 2, 3, this is a pin which is meant for input or output. Input means you can connect a button or a sensor to it, and output means that it can provide a current, a voltage on it, so that we can turn an LED on or off. So if you see my circuit diagram, this is one pin of the LED that goes into G22. This is on G22. This LED then comes to a resistance. These are internally connected, and from a resistance it goes to the ground pin. This is the circuit diagram G22. The longer leg of an LED is called positive. So positive will go to G22, and the other end is called negative. It goes through a 150 ohm resistor. It could be any resistance varying from 100 to 220. You can use any. It will only cost difference on the brightness, nothing else. This is readily available in any local market. When you buy, they might ask you tolerance. You can say anything, plus minus 10%, plus minus 5%, whatever is available you can use. It should be 150 ohm of any type, carbon resistor, metal film, anything you can use, it doesn't matter. And then we have a connection to the ground. So when this pin will receive a 1 voltage, that is 3.3 volt, one signal means 3.3 volt, current will pass and it will glow, and when it will be set to 0, it will get a 0 volt, and 0 volt means that it will stop glowing. So basically we have to program this chip in such a way that on the G22 pin, voltage goes through 3.3 to 0 after 1 second, and we can technically say that we will have to program it in such a way that G22 receives a 1 signal for 1 second, 0 signal for another 1 second. This should keep repeating itself. So now let us come to the programming part. This is my Visual Studio Code starting with platform.io, and this is a view of the actual connection that I have made, and this is the LED, and you can see all that in the picture. This is a live picture of my connection. This pin goes to the computer for programming. After that we can remove it and connect it to an actual power supply. We will not need a computer for that. It will automatically start running as standalone, and this is the resistance. You can see this is a live picture, so I will move it to side for some time so that I can program it. As explained in the previous tutorials, this is our project and platform ini file. This we have set platform as this, board as this, monitor speed should be set to 1150-200 because we want a proper log also to be seen, and monitor filters are for colored view of the log. Then this is the main.c file. This is the file that will be of interest to us, and let me explain the various parts. First of all, we have included a few headers. Then this is our tag which will be used in log. So whenever I see tag blink, I will understand that this message is coming from my own program. Then I have defined an integer blink gpio for gpio number 22. This is the same pin that I have connected, and if you see what it is exactly, we can click, and all these pins have been defined in gpio types.h, and these pins, they correspond to the pins on this device. G22 will mean this 22 corresponding to this pin labeled. So like that, these pins are integral, and I have just defined it conveniently here so that we can use it in our program. Then this is the app_main, the main file. ESP underscore log I is information log. This is the tag and it will say starting. So this tag blink will appear in my log, and when I connect it to my computer, otherwise it will be ignored and will just go on in the program. I can remove it in my release versions also. Then I have gpio set direction. This says that my blink pin, that is this pin 22, will be used in mode output, and a variable is on false. This will keep toggling. This is a while loop I have set. Log information turning the LED off or on depending on the current status. gpio set level, if is on, will invert it on each iteration and it will be either true or false. So when it is true, it will give a voltage of 3 volts, and otherwise it will give a voltage of 0. V task delay is a delay of 1000 milliseconds. So this will be a cycle of 1 second that will keep going here. So before anything, it's time to just compile it to verify that we have everything going right. In the lower left corner, I'll go to build and we will wait for it to build, and it might take long time, and let's wait for it to build correctly, and then we will proceed to our next part. So once we have success, then it is time to upload. I will click on this and I will bring it in view also. So as it will be uploaded, we can then start seeing building in release mode, and once it is uploaded, you will see some sort of this blinking, and this blink means that it is now being uploaded. And once this upload is complete, so upload is complete, and now you can see that it has automatically started running also. This changes after 1 second. This is automatically running now. Everything has been automatically detected. This red pin glows on log message. If you remove all log, this will not glow. So this is autofocus, so that is why you are seeing sort of this blurring and all. So this is how the things work. I'll close it right now. Thank you.